video is more about Chapter 2. Your Chapter 2 book has a lot of material in it and not enough examples, so I will present today some more details and hopefully examples. And why can't I move to the next slide? There it goes. Okay, so questions since last video, and also questions since your last homework. One thing that people saw is why was their program closing even though they put in a get character? That's because the scanf function eats the number from the keyboard, but not the trailing new line. So when you entered a number from the keyboard, you had to press enter, and it didn't. The scanf function didn't see that there was an additional new line. And so you can fix this problem by adding another get character at the end of the program. So here's an example. This is actually from your homework problem, computing the area of a rectangle. Let me show you the example. So the code is right here. These are some additional comments down here at the bottom of the code. But here's the code, how it should have worked in your homework solution. And if you didn't turn in your solution yet, you are going to get dinged for turning in late homework, because now I've put the solution up here, which is not fair to those who did turn in their homework on time. So if I'm going to compile this program, it's actually problem 2028C, so I'm going to go ahead and compile this program. GCC, it's already compiled, but I don't remember which version I compiled. Problem 28.c, make object code, call it problem 28, compile it. I didn't get any compiler errors, so now I'm going to run it. Enter length of the size of the triangle. I'm going to enter 5, or rectangle, sorry, 5. And see, every time I entered a number, I have to press an enter key. So this is an extra hidden new line in there. But you see, my program didn't end up with a blinking cursor. So it put out the answer and it closed right away. And actually, if I looked at that in the GUI world, I go to programs in Chapter 2. I have it compiled right here, problem 28C executable. I run it, enter the lengths of the size of a rectangle, 5, enter, 5, enter, and you see my program closed, even though there's a get character at the end. So how you fix that is to put an additional get character in it to get that hidden new line that was caused by the scanf function. So save that. I'm going to recompile it. Remember, I'm just pushing the up key to get my previous commands. Run it. So there is a 5, enter, 5, enter. And see, I have the blinking cursor now, so it's waiting for one last get character function call. So the program has not closed yet until I press enter one more time. So great, that's how you fix that problem. Back to my PowerPoint here. That's how you fix that problem. Okay, so what is the difference between float and double declarations? That question has come up this week. Within the computer, the difference is how big of a number can be represented. Double will use more memory. So down here, you can see if you declare your variable float, it'll use 32 bits in your computer memory, and it can be a number between these two values. Remember, this is exponential notation here. So that's 3.4 times 10 to the 38th power. Double precision uses 64 bits, so you can represent a larger number with double precision. This isn't the whole answer to this question yet, though, so more to come. What about the int data types? These, remember, have no decimal point, and you cannot express them in, I don't think you can express them in exponential notation either. So here's our int data type. Ints use 32 bits, but if you really needed a really big integer number, remember no decimal points, you could say it's an int long, and you can get a bigger range of numbers. Those aren't decimal places, those are commas there. So mostly for this course we will use character, int, and double, and more on that in just a moment. Okay, should I use double or float for variable declarations? You can say float uses less memory, but is it really significant? Well, the answer is the standard way and the problem-free way to answer this question is to declare all your variables as double. The main reason is because all the math functions like sine, cosine, exp, which is e to the something power, they are all double precision calculations, and they all use double. Float is used when you have large arrays, which we haven't covered arrays yet, and you're worried about your memory management. Additionally, some problems will occur if you declare the variable to be float, but then try to do calculations and conversions. And I will show you an example in this presentation. So assignment statements was section 2.3, and I need to pay more attention to this for the pay more attention to it in this lecture than I did in the last lecture. But the general form is that an identifier, maybe that's the name. Remember, that's the name you give to your parameters, your variables that are in the program. So the identifier equals an expression. So what can the expression be? So here's some examples. Miles is an identifier. And I'm saying miles is assigned to this double number, 5.2. It happens to be in a declaration, so I've declared it to be a double. I've declared this identifier to be double, and the number that I put in memory will be a number with a decimal point that's stored in 64 bits in memory. Here the identifier is x1. It has been assigned 3. We don't say x1 equals 3. We say x1 is assigned 3. Here I have a character variable, a character identifier whose name is node, and I assigned it the value of a. So node is assigned the character value of character data type of a. So an identifier, here's another one called answer, can also be assigned to an expression, like a math expression. So here I have an answer, and it's assigned to this expression. An identifier can be assigned to another identifier. So, for example, rate can be assigned whatever the value of state tax is. So state tax has some value assigned to it somewhere. So whatever the value of state tax is, which I'm calling it by its name instead, by its identifier, rate will be assigned to the value of state tax. In this case, rate is assigned to the value of state tax, whatever is associated with state tax. Maybe it's 7%. Or another example, similar to your homework problem, kilometers is assigned to this expression, which is both a number times an identifier that's associated with another number. Lastly, you can make multiple assignments of identifiers. So x can be 0 can be assigned to z, which can be assigned to y, which can be assigned to x. So going back to using a lot of this float and decimal and int, so numbers that we're dealing with, you should match your assignments and your data types and your calculations. They should be all of the same type, or you can have some problems. And this is an example to show a lot of the problems that can occur. So first of all, here I've assigned a identifier named a, and I've assigned it as an integer 12. Here's an identifier b, which I've assigned the value 4.5, and it's a double. integer c, which the identifier is c, is assigned to the value 9.3, but this is a problem. I said c is an integer, but I assigned it something that looks like a decimal. And so I wrote a little piece of code, and there's a lot to be gained by this little piece of code when we look at it. But I wanted to test what happens when I print these numbers out after I've made these kind of variable declarations. So let's look at my first line of code. It's one and only printf statement, but it's a really long printf statement that I want to put on multiple lines. So I have my first part of my string. Remember, a string is between these string literals, between these double quotes is here, but I wanted to continue to the next line because it was too much to put on one line. So I just go to the next line and continue with something in double quotes. Same here, I'm just continuing to the next line. So all of this red stuff here, all of this red is one big long string with embedded format specifiers. These are the things that start with the percent signs. So it's really just between here and here is one big long string. It just didn't fit on one line, so I had to break it up into these individual lines with more double quotes. And then you see that we have embedded format specifiers or conversion specifiers in this big long string that fits on more than one line. So this is the first embedded conversion specifier or format specifier, and it's associated with whatever the value of a is. The next one's here. It's associated with this value. It's associated again with a, but there's a one-to-one correspondence with the first embedded conversion specifier to the first thing at the end of this printf statement. This one is associated with this value. This one is associated with this value. This one is associated with this value, and this last embedded conversion specifier is associated with whatever the value of this is. I could put something literally here, but I've chosen to put identifiers that have some value assigned to them, which I assigned up here. So one long printf statement, and I can play with all of these different things that happen. So let's look at let's look at it line by line, and this down here is what happens when I run this little one line of code. Remember, it's one line of code, but this printf is one line of code, but it's a very, very long line of code. So the first one I wanted to do was print the value of a, which is an integer assigned to the value of 12. And so this part in parentheses is just telling me what to print to the console. So I print the value of a, and I'm going to print it as an integer. So my embedded conversion specifier, format specifier right here says, give me a field width of 2 and show me and output it as an integer. So that works right. I say a, here's the exact string I put up here, a equals, and then 12 gets substituted in. Okay, that is correct. So this next line of thing, I'm again looking at what a is, but my conversion specifier, I made it a float f, which is float means some kind of a decimal number or fractional number. And so I tried to output the value of a, which was declared an integer, but I tried to use a float format specifier or conversion specifier. And this is the output that I got down here at the bottom. It output all zeros. So basically the program, the compiler, didn't know what to do with it. It's actually an undefined operation in C. In C and in all the C languages, you have to be very precise. You have to be very exact. Actually, a lot of languages are like that. So my next example is I want to look at this B, this identifier B that we declared as a double, and we assigned it a honest to goodness true value that's double. It has a decimal point in it. It's fractional, right? So I'm going to output B. It was declared a double, and I'm going to output it with a float conversion specifier or format specifier, and I look at the output here and it worked correctly. No problem. But now, the next line here, I'm going to try to output B, but I'm going to use an int conversion specifier and tell it to output an int. Well, it outputted an int, it's 0, and there's no decimal point there, so it is truly an int, but once again, it's some kind of an undefined, unrecognized operation within the compiler, and the result is wrong. Lastly, here's C. I said C was going to be an int. I declared it to be an int, but I assigned it a value of 9.3, which is not an int. So then I tried to output it. I tried to output it as a floating point number. See, C is associated here, and once again, I got zeros. So bottom line is, if you've declared, be careful when you declare your variables and then how you want to print them. And this is also going to work with the scanf function, or when you import them from the keyboard, how you want to store them. Be careful that your data types and your assignments match. This didn't match. It didn't know what to do with it. My conversion specifiers and my data types didn't match. I often got zeros. This problem, as well as using printf and scanf, creating problems if you're mismatched. It gets worse when you start doing calculations if things don't match. So in this little piece of code, I've declared an int of 12, and it is an int. A double of b is assigned to 4.5. It's truly a double, and I make that same blunder and call int c 9.3, and then, okay, well, I didn't use c. Looks like I just copied it over from my code. So I'm using A and B, and I try to divide A by B, but I said my answer would be a double. So A is int, B is double, int divided by double, going into an answer that's declared double, will convert, and it will work, and you will get the correct answer of, there it is, as a double answer. So I was allowed to mix these up, but it's kind of a trick actually. It only works if one of these, in this case B had a decimal in it, it only works if one of these numbers had been a double. Sounds complicated, right? The point I'm trying to make is that when you write your code and it's got to do some calculations, be really, really consistent about declaring all of your variables, your identifiers, whatever they are, to be consistent. They're all ints. Your answer you expect is an int, so you declare everything to be an int. That's okay. Or you might have fractional answers, and so you better declare everything to be doubles and not mix them up with the ints. So I'm just trying to show you some examples of problems. Okay, here I said my answer was going to be an int instead. 12 divided by 4.5 does not give you an int answer, but I tried anyway, and it came, and even though I tried to say output it as, this is just a format code in a way right here, this float, and it gave the answer as 0. So again, it didn't know what to do with it. A was an int divided by B, which is a double. I tried to give an answer in an int, and it's wrong. So more examples, and when you do your homework, you're going to get challenged to do this. If I were you, I would write your own piece of code. Even though I'm not asking you to submit a program for all of these, I'm going to ask you what the answer is. I would program all of that and check yourself. So here, notice instead of putting some kind of, I have a printf statement, but out here where we before had identifiers of some sort that would substitute into these embedded conversion specifiers. But look, I can actually put some expression out here and have it do the math and then output it according to whatever I've specified in my printf function. So I'm actually doing these calculations on the second part rather than saying A, B, C or some other identifier. So in this first one, I'm saying what is 9 divided by 5? But there's no decimal points here. This is an integer, just as I've written it. It is an integer. It is an int, and this is an int. What is 9 divided by 5? It's something fractional, isn't it? But it's an int, and it's an int, and I say output it in something that's fractional, in a fractional format. But it turns out I'm dividing int by int, so the compiler only wants to give an int answer. It doesn't know what to do with that, so it gives you zeros. Here, my next try, I said 9 divided by 5. 9 is an int, 5 is an int, and I want to output an int with my printf function. This one worked. It worked correctly, but there's a catch. So how many times does 5 go into 9? It goes one time with a remainder of 4, right? But this is an integer calculation, and they're with an integer result, so it can only say that 5 went into 9 one time. It can't say 5 went into 9 one time with a remainder 4. So at this point, my code will output a 1. So I said, okay, this is a problem. So now I have 9 divided by 5 again, but I say 9.0. This is automatically now a double in your computer program. So I have a double divided by an int. I want to output a floating point number. It worked correctly. No problem. That's the correct answer. Next one is I have a double, 9.0, divided by an int, and I try to output an int answer, and I get some kind of program doesn't know what to do with it. It's undefined. I get crazy undefined answer. Here is 9 int divided by 5.0, which is a double, and I say output a double answer. No problem. It's correct. It's a double answer. This is a double answer with a floating point format. Now I say the same thing, int 9 divided by 5.0, which is a double number. I try to output as an int. Doesn't work, get an error. 9.0 is a double divided by 5.0. It's a double. I say output it as a double with a floating point format. Works just fine. 9.0, which is a double, divided by 5.0, which is a double. Output it as an int. Doesn't work. You get an error. In the last video that I made, I talked about the precedence of the arithmetic and assignment operators. This is a repeat of that slide, but I'm going down at the bottom. I've added this little red part here that just summarizes it. So any calculations that you have your program make, it's going to do what's in parentheses first, followed by the multiplication and the division, followed by the plus and minus things, followed by the inequalities, and then the logical expressions. So you have to be careful when you write an equation in your code that you are aware of what order your program is going to work the equation. So I have some examples. More examples. So here I have an equation, 16.0 divided by 2. Now that's a double divided by an int. And then I have 14.0 divided by 2. Double divided by an int should result in a double plus another double. But what is the answer? It isn't. It's going to do all the multiplication and divisions before it does the addition. So this will be 8.0, this will be 7.0, and I said to output as a floating point number. So 8 plus 7 is indeed 15. Down here is the answer. 15 is indeed a floating point double precision number that has been outputted. What is 4 plus 2 plus 3? It's not 4 plus 2 is 6 times 3 is 18. The answer is not 18. The answer, it'll do the multiplication first. So it'll do the 2.3, which is 2 times 3, which is 6. Then it will do the addition, which is add 4, and the answer will be 10. This is an int. this is an int, 4 is an int, 2 is an int, 3 is an int. So I'm saying output an int, I get an answer that's an int. See, there's no decimal point, and it is the correct answer. The next one, which you may or may not have seen before, is called a modulus operator. It looks like a percent sign. Basically, modulus says, tell me what the remainder is. So 14 modulus 2, or 14 mod 2, means what is the remainder of 14 divided by 2, which is a 0. 50 modulus 10 is 50 divided by 10, which the remainder is 0, so the answer will be 0. 50 divided by 9 is 49 with a remainder of 1. Is 9, because 9 times 9 is 49. So 50 divided by 9 is 9 times with a remainder of 1. So that's what the modulus operator means. So going back up here, I said 14 modulus 2, which is a 0, times 5 is 0. Everything in here is an int. By the way, when you do modulus, it has to be int, because it's an integer number divided by an integer number with an integer remainder. So my output there is an int. Next one is 15 modulus 2. So 15 divided by 2 goes 7 times, because 7 times 2 is 14, and the remainder is 1. 1 times 5 is 5, so the answer is 5. More examples. So here I have, so I take a first look and I say everything's an integer. Let's see what happens. So 16 divided by 2, everybody's an int. You get an answer of 8. But look at this one, 15 divided by 2, everybody's an int. The answer is 7. It's actually 7.5, but can't use 7.5. You just get 7 as the answer. So now it becomes 8 plus 7 is, the answer becomes 15. Output it as an int. So it's not accurate. It's not the answer you want if you were trying to write this in a computer program. Getting a little bit better example of that, what's 7 divided by 4? 4 goes into 7 one time, and then there's a remainder amount. And I'm saying output an int, so I get 1. But the 7 is 7 divided by 4 really 1? No. So I said, oh, that's not the right answer. So now I try 7.0 divided by 4. That's a double number divided by an int number should give me a double answer, but I said to output it as an int, so compiler didn't know what to do with it and gave me a 0. So still haven't solved this problem yet. So now I said 7.0 divided by 4.0. I have double divided by double. I output double with a floating point format. I get the right answer. That's the correct answer. So one more thing you could do, I could have said 7 divided by 4. They're both integers, but I can put in front of it, this is called a cast operator. It means you cast it into a different data type. So I did a 7 divided by 4, but before I did that, I cast it into a double operation. So it made it the answer be double. I output it as a double, and look, I got the right answer. So the next part in your textbook talks about writing a lot of these equations. And I decided to do an example. It's one of the examples in your textbook that they didn't tell you much about the example, so I thought that I would do it. The main thing about writing the equations is you have to be very, very aware of the order of operations, the fact that multiplication and division is done before the addition and subtraction. Also, I highly, highly recommend using lots and lots and lots of parentheses so that you're sure that everything is done right. Another thing that you can do is calculate the numerator of a big equation separate from the denominator, and then do a something like an answer equals numerator divided by denominator. So this slide right now is on page 40 of your textbook. There's a practice section down at the bottom. And the answers are in the back of the book, I know. But the answers are just, this is how you would write the equation in C. So the answers look like plus signs, multiplication signs, division signs, and lots of parentheses. So I looked at number 2 in that practice on page 40. And basically you're just supposed to write the equation and for the tension in a chord. But the book doesn't tell you anything about the problem. So I thought it might be nice to see what they mean. What is the tension in the chord? So the picture on this slide shows you the equation and what the problem is that you're trying to solve. So you have two weights on a cord through a pulley hanging with the force of gravity, and you want to know the tension, which is a force that's on this cord, how much tension force is on this cord. This is the equation. The equation is also in your book. And so remember, when we're solving, writing a program to solve a problem, you have to go through a process. The first process is to clearly state what the problem is. I didn't write it down here, but clearly to state the problem, say I want to find the tension of two weights hanging on a cord in a pulley system. The next step is determine what the I/O is, or the inputs and the outputs. So my inputs are the two masses, or the weights, mass 1 and mass 2, and the output is what is the force of tension. At this point, before I start writing any code, I better decide what kind of data types this kind of calculation, this program should need. Are these M1, M2, and output, are they ints? Are they doubles? Are they floats? Are they characters? So I said earlier that when you do calculations, make everything a double. And then before I go and write the code, I want to do a hand calculation so that I have some data that I know is good that I can test the code with. So there's my hand calculation right here. I put some numbers in the equation. I use a 10 kilogram, a 5 kilogram weight. 9.8 is gravity, the force of gravity, 9.8 meters per second per second. So I'm going to show you the example now, and then I'm going to mess with it after that to make a point out of some of the other things I said in this lecture. So let me mess with it now. So here is the code as I've written it. Just ignore this green stuff down at the bottom. This is little pieces of code that's been commented out. But in the course of making this lecture, you can see that I pulled out pieces of code. I put it up here, and this whole C program just says examples at the top. It's a file that I made called examples. So these are already examples I'm done with. They're at the bottom of my code. They've been commented out. They don't affect anything. Okay, so let's see. First things I want to point out in this program, which is just going to compute the tension on this cord. I did not have to put an int before the main for this program to work. So putting an int there and putting a return statement at the bottom is saying that after my program executes, I'm going to return 0 means return an integer value of 0 to the compiler. If you have some value that's going to be returned, like an int, you have to write that in front of the main, like that. And then if you have some value, I could return a double, I could return an int, I could return a character, but then you would have to have a return at the bottom here. So this is a pair. Later we'll be writing our own functions, and the function might return some calculation. It might be a double, but when we write our functions, they will have to have a return, and then the returned value has to be of the type that's defined up here. But this this program actually did not need a return statement, neither did it need to have the int statement. So what does my program do? I declare some doubles in the beginning, 9.8 for gravity, and a double called tension underscore n, because I like to keep track of my units when I'm doing engineering programming. Tension has units of newtons. Another new thing here, you see slash, and I wrote units of G are in meters per second squared. So this slash is a line comment that you can put at the ends of your line. You can also put them inside your code somewhere, but I use them at ends of line. That's opposed to what we do at the top of our program. At the top we have the slash asterisk slash, and we put in our preamble information, or all our information about a program. This up here is called, I'll just type it in, this is a block comment. And down here, this one is a line comment. So that's a line comment with the slash. And you can put line comments wherever you need to make sure that somebody who looks at your code knows what it is. In my case, I like to keep track of what the units are. I am using an SI system of units here as opposed to pounds of force. I'm using newtons of force instead. I'm not using English. And then my outputs, and I could have put this all in one line, but I have it on 2 lines because I played with the code a lot. My inputs are also the mass of 1 in kilograms and the mass of object 2 in kilograms. So I want my program to say, please enter mass of object 1 in kilograms. So I did a printf statement, and I get the keyboard input. It's a floating point number. It's been declared as a double. I store it in this identifier called mass 1 kilograms. I do the same thing. I get the mass of object 2. I store it in mass 2 underscore m2 underscore kilogram. Everything matches, double matches, floats match. It all looks good. My output, calculated output tension, I make the calculation right here. So you see it's 2 times this value divided by, and I was very careful to use parentheses here for the denominator. If I don't use parentheses for the denominator, if those parentheses weren't there, you will not get the right answer. And then times gravity. Gravity is not in the denominator. It's not in the parentheses here. So the way this will calculate is the multiplication will be done. This multiplication will be done, and then it will be divided by the things that are added up down here. And then I put my answer out, and notice I've had to use the to get characters because I've used the scanf function, and there's an extra new line floating around. So save this program, run this program. This program is my examples. Okay, it's my examples. GCC, right click, left click and hold. That selects it. Right click, -O, right click it in, get rid of the .c extension. Okay, and now compile it. I compiled it. No errors. Good sign. I make errors. I try to fix them before I write this. Please enter mass of object 1 in kilograms. I'm going to put 10 because that was one of my numbers that I did my hand calculation on. Please enter mass of object 2. It was 5. That was my hand example. Total tension is 65.33 newtons, and it did match my hand example, so yay, it's right. My cursor is sitting there blinking because I put in an extra get character, so the program didn't close. Okay, so that was the proper solution, but let's show you some of the things that may have gone wrong. It went wrong for me when I first wrote the program, so I played around with it. So the first thing that I did wrong is instead of declaring these as doubles, I had declared them as floats. But recall that anytime I'm going to be doing calculations, they're going to be in doubles. And so anyway, I declared those as floats because I was thinking float, scanf, it's a float. Doesn't exactly mean that. And do this calculation, declare everything a float, and let's see what happens. Save it. Recompile it. Rerun it. So enter the number 10, enter the number 5, and I got the answer was 0. And I thought, what? You know, the answer can't be 0. That's not right. What have I done wrong? So then I decided to say, okay, what's happening in this program? And I'm going to show you some of the tricks to troubleshooting your program along the way. So the first thing I thought was, did my keyboard entry from the scanf function, did it not store properly in my M1 underscore kilogram identifier? So I wanted to check to see if it stored properly, and how I did that was put in, now you wouldn't turn this in to me, you want to turn in your final code with no extra lines of code or unnecessary lines of code. But for troubleshooting, I can put in some extra lines of code. Whoops. So I put in this extra line of code that says, okay, my program asks the user to input the massive object and enter the massive object 1. User enters it, but then I put a printf statement in here so that I put back out what was stored in mass 1 kilogram. What was stored for that value of the weight. So I output it back to the screen so I can see what was exactly stored to see what the problem was. So save that, recompile, rerun it. 10. So it didn't store the right value. It didn't store my 10. So I knew right away there was a problem. And of course I get in the end the wrong answer. So I use this printf statement, and I can put them anywhere as I'm going through the code to see if I have some kind of a problem. So the problem was that that this is stored as a double, but I called it a float, and so therefore the program, it was undefined. It didn't know what to do with it. It didn't store the value correctly. So one thing you can do as you're troubleshooting your code, and you're adding these extra lines in to check yourself, you can comment them out. Okay, I'm done with playing with that printf function. I'm going to go down here maybe and try another print to see what's happening. But I don't want to delete it right now. I might still use it. So I just commented it out. So when the program goes through and executes, it just skips that line because it's been commented out. So that was useful to me. So I want to go back and make this a double. What if, now you notice I was entering integers on my keyboard, right? But then I was saying that the numbers entered will be stored as a floating point number. But what if since the user was entering ints, what if I declared mass 1 and mass 2 to be ints? What will the program do now? And I think I'll leave this printf out to see what happens. I'll leave it in so I can see what happens. Save it. Recompile. Rerun it. So please enter massive object 1. I'm entering the int of 10. And it didn't store correctly, so it stored it as a 0, so I knew that was incorrect. 5. Enter. So that didn't work, so you need to be careful on that. Let's change that back to double. What else went wrong in this program? I don't need this printf anymore. Commenting it out for now. Don't send me code that has your troubleshooting code in it. Don't comment it out and send me your troubleshooting code. Clean up your program, make it nice, make it a final product before you send it in to me. Oh, so another experiment we could do, I'm going to do this back. I'm going to save it as an int. So what if I save it as an int down here with my scanf? Save it as an int. What does the calculation do? Because I asked for a double in the end. So what does the calculation do? Save. Oh, it still didn't like it. 5, enter, and the answer is 0. Oh, my mismatch, right? I called it an int there in the scanf, but up here it was a double. Let's make this an int so we can see what happens. So these identifiers, massive 1 and massive 2, are declared as ints. I get them from the user. I store them in an int. I get them from the user as an int, store it over here into its proper location, and then I want to check, did it store as an int? So let's change that. Did it store as an int? I want to see if it did store as an int. And then I'm going to make the calculation right there and see how the program works. Recompile, rerun it. 10. Yes, 10 got stored. See, I entered massive object 1 and 10. It got stored as a 10. That was my extra printf function. And the next one is a 5. I'm going to assume it was stored as a 5, although I didn't put that additional printf in there for troubleshooting. And I got a calculation of 58.8. That's not the right number. The right number was 65 point something. So you can see it made the calculation, but it must have made it all as an int here, which means like when we did 7 divided by 4, the answer was 1. So the answer is off. So I'm going to try one more thing. I'm going to see if this will work, if I can cast it as a double salute in the answer and see if that will work. Ten, 5, and it does work. So I could cast the answer even though the user entered integers, and I stored everything as an integer, an int, but when I made my final calculation, I cast it first to be a double, and it did work. So that was what I was doing. I was playing with this. I suggest you play with it, learn a lot about making sure that your variable declarations are of the correct data type, or your declarations are of the correct data type, and your calculations are using the correct data type. So once again, here is the copy of the code in case you want to pause and capture this information for some of the programs that you are writing. This is the incorrect copy of the code because it says float there and float there, and that will not give you the right answer. It needs to say double and double there. Let me go back and give you the correct code. Final screenshot. Everything should say, clean up my code. It should say a double. You should not be turning in any of these extra print statements in there. Just put in some nice white space to make it look pretty. This is the body of the program. So these are my declarations up here. This is my body of the program right here. This should be a float number. This should be a float number. I do no longer need to cast it because everything has been made a double. I make calculations that everything has been stored as double. I make all my calculations as double, and this is a clean and final answer that you would, well, fill in the correct header information up here. This is a clean and final answer that you should submit if you were submitting this type of a problem.